All right. In this video, we are going to talk about the functional group ester. So not ether, this is an ester. Well, what is an ester functional group? You're going to start with an alkyl group, so some R group, carbon, double bond oxygen, to an oxygen. So it looks a little bit like carboxylic acid, except that oxygen goes to another R group. We'll call that R prime. It just means it's different than the first. It could honestly be the same, it's just it doesn't have to be. So an ester has the single bonded oxygen sort of looks like an ether. If you were to kind of cover up this top a bit, you would see an carbon, carbon, oxygen, carbon. So it looks a little bit like an ether. But because it is attached to that carbon double bonded to an oxygen, it changes its functionality quite a lot. And also changes how we build them. So there are far more esters, where there were very few ethers. So ester groups are a little bit funny in how we name them. So let's do an example. So here's 2 carbons, oxygen, and let's make it 1 carbon coming off. Problem is, there isn't a single carbon chain. Look, I've got a carbon here, I've got a carbon there, so there's a 2 carbon chain on the left. But that oxygen interrupts it. While there is a 3rd carbon, it is not attached to the other 2. This means we can't include all the carbons along the kind of line as one continuous chain. They're not. They are 2 separate ones. So what we do is the carbon that is part of the double bond to oxygen, that is our main carbon. So here is carbon 1, here is carbon 2. Well, way over on the other side I have a 1 carbon group. And so we would think, oh, that must be some kind of meth. When we go to name it, what actually happens is we break it into 2 parts. So we divide where that oxygen split things up, and we say 1/2 is a double bond to oxygen side, and 1/2 is a single bond to oxygen side. So there's the C double bond O side, and there's the C single bond O side. When we name an ester, we actually break it into 2 parts. Okay. So the first part, so our part that we're going to put out front, is the single bonded oxygen side. And so this is a methyl space, and this is one of the first times we have space in a name. And then our second side. Our second side is the part we actually name as the ester. And the suffix for esters are 08. So as I look at this double bonded oxygen side, I say it's 2 carbons long. 2 carbons is an eth. Those carbons are single bonded, so it is an ethan. And it is an ester, so it is an ethan 08. This is methyl ethanoate. And so esters are one of the few functional groups where you actually have a space and you break it into 2 parts. This stems from how they're made. How you actually make them is you have a carboxylic acid and you have an alcohol. And they combine to make an ester, and they remove 1 oxygen, 1 hydrogen, and 2 hydrogens. So water ends up breaking off, the rest of the molecules link together. And so we used to name it as an ethanoic acid and a methanol. When we combined them, we said it was methyl ethanoate. We just used the original components' names to build it. And so this is still how we name esters. So let's try a few different lines. If I have Let's try that, and let's try that. Give a shot and name these two, and then come on back and we'll work through them. Alright, if you gave them a shot, let's talk our way through. So over here on the left, well, my single bonded oxygen side is 2 carbons, so we're going to call this one an ethyl. And my double bonded oxygen side is 3 carbons, so it's a propanoate. So this is ethyl space propanoate. Ethyl propanoate. If we go over to our rightmost structure, well, again, I've got my single bonded oxygen side is 2 carbons, it's ethyl. My double bonded oxygen side, this one's a little bit different. Again, I have 3 carbons, but I have a subgroup. So 3 carbons is going to be a prop. The carbons are single bonded to each other. It's a propan, and it is a propanoate. But this time it's got a 1, 2, 3. So the carbon double bond oxygen is number 1. So the 2 position is a methyl. So there's a 2-methyl. And now I need to put that ethyl out front. So ethyl space 2-methyl propanoate. And so the ester on our left here is an ethyl 2-methyl propanoate. Ethyl tells us that the single bonded oxygen side's carbon chain is just 2 carbons long. And the 2-methyl prop tells us I have a 3 carbon chain with a methyl off the second as part of my double bonded oxygen side. So ethyl 2-methyl propanoate. So this is the idea of naming esters. You have to identify the 2 different sides. And it doesn't matter how you draw them. You'll notice I have the double bond oxide on the left in all these, but you can freely have an ester like this. It doesn't matter which direction you draw it. What we find is that there is still a single bonded oxygen side. So this is 2 long with a methyl at, now this is important, at the 1 position. So if you have to mention subgroups in your single bonded oxygen side, the carbon attached to the oxygen is carbon 1. So this is a 1-methyl ethyl for the single bonded oxygen side, and this is an ethanoate for the double bonded oxygen side. So the name is 1-methyl ethyl space ethanoate. And so if you flip the molecule around, it doesn't change the fact that the single bonded oxygen side always has its name up front, and the double bonded oxygen side always gets the O8. And numbering is always, well, if I had to number my main chain, it would have been 1 and 2. Since there was nothing coming off at this time, I didn't need to mention any numbers. And if I have to talk about things coming off the single bonded oxygen chain, well, then the numbering starts from the carbon attached to the oxygen. And so you actually have 2 different chains that get numbered, which is why we need 2 different names. It is very possible to have a structure where you would have to mention numbers off both chains. So if we wanted to give this one a shot, we should give that a shot, and we'll make this our last example. Alright, if you gave that a shot, single bonded oxygen side, carbon 1, carbon 2 with a methyl, it's a 1-methyl ethyl. And then for a double bonded oxygen side, it's 1, 2, 3, it is a 2-methyl prop. And then because it's our main chain, it's a propan O8. And so we'd combine it. 1-methyl ethyl space 2-methyl propan O8. And so because esters effectively have 2 carbon chains, we have to do this broken up space in the middle and really talk about 2 different naming structures. And so the single bonded oxygen side is always out front and ends in a YL to tell us that it's the single bonded oxygen side. And the double bonded oxygen side gets named just like any other main chain. You tell the subgroups are, you figure out your AN, EN, YN, and then you put on your functional group suffix at the end. And that is Ester Naming.